Hello everyone. Today I will present my machine learning project, our customer churn prediction using a Telco customer churn dataset. The objective of this project is not only to build an accurate predictive model, but also to evaluate the model from perspective of responsible AI. In modern machine learning applications, especially in customer analytics, models should not only achieve good performance but also be transparent, interpretable, and fair. Therefore, this project combines predictive model with a fairness evaluation and explainability techniques. Customer churn refers to a situation where a customer stops using company service in subscription-based industries such as telecommunication. Predicting churn is extremely important because retaining existing customer is usually much cheaper than acquiring new ones. By identifying customers who are likely to leave, companies are implement targeted retention strategies and improve customer relationships. The dataset used in this project includes customer demographic information, service subscription, and billing information. Example of features include gender, whether the customer is a senior citizen, contract type, internet service type, monthly charges, total charges, and how long the customer has been with the company. The target variable is churn, which indicates whether a customer left the service during the processing. I convert the total charges variable into a numerical format and remove rows with the missing values. The customer ID column was dropped because it is only an identifier and does not contribute to the prediction. Categorical variables were encoded so that machine learning algorithms could process them. Finally, the dataset was split into training and testing sets using satisfied sampling to perceive the class distribution. To determine the most suitable predictive models, straight-out algorithms were trained to compare logistic regression, random forest, and XGBoost. Each model was evaluated using accuracy F1 score and ROC AUC. The benchmarking results shows random forest achieved the highest F1 score, approximately 0.6, 0.7, while maintaining strong accuracy and ROC AUC values. Because the F1 score balance precision is a recall and is particularly useful for imbalanced classification problems such as churn prediction. Random forest was automatically selected as the best performing model. After selecting the best model, the next step was to evaluate using responsible AI principles. One of the most important aspects of responsible AI is fairness. Machine learning models trained on historical data may unintentionally learn patterns that reflect social or demographic bias. Therefore, it is important to verify that the models has not systematically disadvantaged certain groups. In this project, fairness was evaluated across gender groups. The fairness analysis table shows the selection rate and accuracy for female and male customers. The selection rate for female customers is approximately 0.327, while the selection rate for male customers is approximately 0.334. The difference between these values is reflectively small. In addition, the prediction accuracy for both groups is almost identical, around 77%. This result suggests that model behavior consistently across gender groups and does not strongly favor one group over the other. Performing this type of fairness analysis helps ensure the predictive model align with responsible. Actually, the next important aspect of responsible AI is the transparency and actually the interpretability. Machine learning models are often criticalized for being black box, meaning that it cannot be difficult. It can be difficult to understand how predictions are made. To address these issues, I used SHAP, which stands for SH Apply. Addictive explanation. SHAP provides a global explanation of how each feature contributes to the model's prediction. The shape customer summary plots show how provides a global view of the model behavior. In this plot, each point represents the customer, and historical axis shows the impact of each features on predicted churn probability. For this visualization, we can see the several features having strong influence on churn prediction. Important variables include contract type, churn online security, internet service, and monthly charges. These results align with real-world business institutions. For example, customers with shorter are generally more likely to churn because they have weaker relationship with the company. Similarly, flexible contract types can make it easier to customer to leave the service. While SHAP explains the models globally, it is also important to understand individual predictions. For this purpose, I use LIME, which stands for Local Interpretable Model Explanations. LIM explains the prediction for a single observation by approximating the model locally. In the example showing the data visualization, the model predicts that a particular customer has a churn probability of about 27%. LIME highlights the feature that most influence this prediction include contracted type to online security, total charges, internet service, and monthly charges. For instance, a short term for this percent of certain service can increase churn risks. Local explanations like this help decision makers understand why a specific customer is considered at risk and can support targeted retention strategies. Beyond fairness and explainability, ethical consideration must also be addressed. Machine learning models is trained on historical data may inherit patterns that reflect past inequalities. As a result, it is essential to introduce fairness evaluation and interpretability techniques during the model development. In addition, when developing such models in real-world systems, organizations should implement model training mechanism, written models predictability, and human oversight in important decisions. In conclusion, the project demonstrates how machine learning can be used to predict customer churn well, incorporating responsible AI principles. The workflow included data processing, training, and benchmarking multiple models, selecting the best performance model, evaluating fairness across demographic group, and explaining prediction using SHAP and LIME. The random forest model achieved the best predictive performance and show a relatively balance between across gender groups by combining predictable accuracy with fairness, evaluation, and interpretability. We can develop machine learning systems that are both effectively and oh, so that's finished. Thank you so much.